All right, hello everybody. Last week we talked about inequalities and we solved inequalities. Mostly did a pretty good job. That's with these inequality signs, less than, greater than, less than, equal to, greater than, equal to, and then we put them on a number line, open circle, arrow to the left, or maybe it was a filled in circle, arrow to the right, all that good stuff. And this week we're going to be solving compound inequalities. If you think of compound words or compound sentences, compound inequalities means that there's more than one inequality within the same inequality. Okay, there's more than one at the same time. So what we're start talking about is these two sentences right here. Okay, this first sentence is raining and it is sunny outside. In order for this whole sentence to be true, in order for this entire sentence to be true, it needs to be both of these things outside, right? It needs to be raining and sunny outside. Okay, if it was just raining and it was cloudy, then this whole sentence would be a lie, right? Or vice versa, if it was just sunny and not raining, then this whole sentence would be a lie. So in order for this whole sentence to be true, we need both to be raining and for it to be sunny. Okay? All right, then the second sentence, it is raining or it is sunny outside. In order for this whole thing to be true, in order for this whole sentence to be true, it only needs to be one or the other. Okay? If it's raining, then the whole sentence is true because it says raining or it is sunny. Vice versa, if it is sunny and not raining, again, the whole sentence is true because it only has to be one or the other. Okay, so the first one again, in order for the whole sentence to be true, it needs to be both of these things. Whereas in the second sentence here, it can be one or the other. Okay, and we need to keep that idea in mind when we think about compound inequalities. Because when we think about compound inequalities, we deal a lot with and or. Okay, and or. So the first examples we're going to look at are and compound inequalities. Okay, so here's an example of an and compound inequality. You could say something like 8 is less than 3y minus 7, which is less than or equal to 23. So notice this 3y minus 7 is bigger than 8 and less than or equal to 23. It's sandwiched in between those things, so it is both of those things. All right, so to solve this compound inequality, we do what we normally do, except it's kind of cool. We can add, when we add 7 to get the y by itself, that's our goal. When we add 7 to all three quote-unquote sides of this inequality. Okay, so then we'd have 15 less than or equal to 3y less than or equal to, oh sorry, that's I messed up my sign there. Less than 3y, which is less than or equal to 30 now. 23 plus 7 is 30. Okay, then to get this by itself, we divide all three sides by 3, and 5 is less than y, which is less than or equal to 10. And there you go. This is your answer. Y is bigger than 5 and less than or equal to 10. So if we graphed our solution, to this compound inequality, still use a number line, right? And then the two numbers we have to deal with are 5 and 10. Y is greater than 5, so that's an open circle with an arrow to the right. Y is less than or equal to 10, so that's a filled in circle with an arrow to the left. Now let's think about what our solution is. Okay, our solution in this situation is everything that's in between 5 and 10, because y has to be bigger than 5 and it has to be less than or equal to 10. So our solution is going to be everything that's in between 5 and 10. Okay, and we call that solution an intersection. Okay, for ands, the solution is called an intersection. And the next thing we need to look at is a compound OR inequality. Okay, an OR inequality is just slightly different. This is an example of an or inequality. X plus 6 is less than -4, or 3k is greater than or equal to 15. And remember now, one or the other can be true. Either this can be true, or this can be true, okay? So we need to solve for both of them because either one can be true still. So this first piece, if we subtract 6 from both sides, we'd have x is less than -10. Or, if we solve the second one, divide by 3 on both sides. Sorry, that should have been x up there. If we divide by 3 on both sides, x is greater than or equal to 5. Okay, so now let's think about it. One or the other can be true. Either x can be less than -10, or x can be bigger than or equal to 5. So if we graph our solutions on a number line again, the two numbers we're dealing with here are -10 and 5. Okay, for -10, x can be less than -10. The smaller numbers are smaller than -10 are to the left here. X can be bigger than or equal to 5, so that's a filled in circle on 5, and x can be bigger than 5. Okay, so there's your graph to this compound or inequality. And most of the times, they will be going opposite directions of each other, and the solutions could be any of these numbers to the left of -10, or it can be any of these numbers that are bigger than 5. Okay, so most of the compound inequalities that you see will be like the two examples that I did for you. Most ands will be an intersection, and most ors will be running away from each other, okay? But the other two options can happen, okay? So I do want to talk about those quickly. If you end up with an and intersection, an and compound inequality, and they do not intersect. Okay, let's think about it. This is saying, let's put numbers here for fun. Let's say this is 2 and this is 3. Let's say I want all the numbers that are less than 2 and all the numbers that are bigger than 3. Well, think about what the solution would be. There are no numbers that are smaller than 2 and bigger than 3. So an and where they don't intersect, that's an example of a no solution. Okay, and then vice versa, an or where they do cross each other. This is saying, let's use the same numbers, 2 and 3. I want all the numbers that are bigger than 2 or all the numbers that are smaller than 3. Well, if you pay attention, these two arrows are going to cover every single number in the entire universe, right? Because it can be this first arrow, all the numbers that are bigger than 2, or it can be the second arrow, all the numbers that are less than 3. So between those two arrows, they cover every single number there is. So this would be all real numbers as a solution. Okay, so it is not something that happens a ton, but it will happen sometimes. Again, an and that doesn't cross, well, that means that there is no number that does that thing. Okay, that's a no solution. And an or that they do intersect each other, they do cross each other, that means that it's covering every single number possible. Every number would make sense for that particular compound inequality. All right, so let me know if you need help on this stuff. Let me know if you have questions based on this video. I know I only did one example of each, so if you need an extra example, please let me know, and I'll try to help you out with a couple extra examples. Have a good rest of your day, and we'll catch you later.